This video is division properties of exponents. In your textbook, it will be helpful to be on page 453. I'm just going to walk right through the lesson. Just make sure you have your book open to page 453. We're going to start with dividing powers by bases. We're going to look at the example that they have near the top there, where it says 5 to the 6th power over 5 squared. I want you to think about, what does 5 to the 6th power mean? Yes, it means 5 times itself 6 times. 1, 2, 3, 4, 5, 6. Okay? And 5 squared means 5 times itself twice. Now, if you think back to the properties of fractions that you know, what do you know about fractions when you have a number in the numerator and that same number in the denominator? Yes, you can cross them out because 5 divided by 5 is 1, and 1 times itself is itself. And so I had a 5 in the denominator and a 5 in the numerator. But guess what? I have another 5 in the denominator and another 5 in the numerator, so I can cross those out. So I'm left with 1 on the bottom, and I'm left with 5 times itself 4 times, or 5 to the 4th over 1. Well, 5 to the 4th over 1 simplifies just to 5 to the 4th. Do you see another way, looking at this problem, that we could get to 5 to the 4th? Think about your properties of multiplication with exponents. Think about what you did there. What could we do with division? Yes, Lila, 6 minus 2 is 4. So could we take the exponents and subtract them as long as my base number is the same? Absolutely. So if you look further down on page 453, it gives you a property. If it's a property, it means they've tried to find a counterexample and have not, so it has become a property. It says for every non-zero number a and integers m and n, a over a to the m over a to the n equals a to the m minus n. Okay, so that's basically saying when dividing exponents with the same base, subtract exponents. Oh yes, what if that when you subtract it becomes negative? We'll get to that. You know those properties. So here's your example. 3 to the 7th over 3 to the 3rd becomes 3 to the 7 minus 3, which becomes 3 to the 4th. Okay? Example 1. Let's go through a few of these. Example 1 is a, and here's our example for your negatives. A to the 6th over a to the 14th becomes a to the 6 minus 14. It's always numerator minus denominator, which becomes a to the negative 8. Uh-oh, negative exponent. What does that mean? Exactly, Clayton. 1 over a to the 8th. Okay, do you see? Just remember that progression. Let's look at example B. C to the negative 1, D to the 3rd over C to the 5th, D to the negative 4th. Okay? It becomes c to the negative 1 minus 5, d to the 3 minus negative 4. Okay? Let's do the math. C to the negative 6, d to the 7. How do we go from there? Well, we have a negative exponent, which means it's got to be dropped to either the numerator or the denominator, depending where it is. If I don't have a fraction, it's going to drop to the denominator. So c to the 6, where's d to the 7 going to go? The numerator, d to the 7. Okay? Let's do a couple of quick checks. Those are found on page 454. Let's do B and E. B and E. B is z to the 10th over z to the 5th, which becomes z to the 10 minus 5, right? Same base, subtracting exponents, which becomes z to the 5th. Okay? Let's look at E. X squared, y to the negative 1, z to the 4th. X squared, y to the negative 1, z to the 4th. Over x, y to the 4th, z negative 3rd. Okay, let's look for the same bases. What do I have that's the same base? X. So I have x squared minus 1. Okay. Y. Y to the negative 1 minus 4. All right. And z. Z to the 4 minus negative 3. Let's simplify that. X to the 2 minus 1 would be x to the 1st. Y to the negative 1 minus 4, y to the negative 5th. Yes. Z to the 4 minus negative 3 is z to the 7th. Okay? Now, we have a negative exponent, so we're going to need a fraction here. So we have x, z to the 7th, y to the 5th. Okay? That takes care of dividing powers with same basis. Let's move